Hello again. Thank you for coming back to watching our fifth video. In this video we are going to be discussing three important rules in differentiation. The product rule, the quotient rule, and the chain rule. So we are going to be deriving them using the equation for instantaneous rate of change. So the first rule that we're going to be discussing is the product rule. So we want to have some derivative, we want to have the derivative of f of x times g of x. So if you remember from the last video, we stated that the derivative is not equal to the derivative of f times the derivative of g. And we're going to be proving that. And once again, we're going to be needing some algebraic manipulation to be able to determine this. So first, let's use the instantaneous rate of change formula. So we have f of x plus delta x times g of x plus delta x minus f of x g of x divided by delta x, and we have the limit as delta x approaches 0 of this. So by algebraic manipulation, we have to add and subtract the following to the numerator. So we're adding and so we're basically adding by 0, but we're adding and subtracting this f of x plus delta x times g of x. We're going to be adding and subtracting this to the numerator, and you'll see why we're doing that in a second. So this equals limit as delta x approaches 0 of f of x plus delta x times g of x plus delta x minus f of x g of x plus f of x plus delta x g of x minus f of x plus delta x g of x divided by delta x. Okay, so now let's kind of mix this around so that we can have a couple nice expressions. So this equals limit as delta x approaches 0 of f of x plus delta x g of x plus delta x. Let's take this minus f of x plus delta x times g of x. Now let's just put this all into one term. Plus, let's do another limit as delta x approaches 0, because we know that when you're adding you can do separate limits, and when you're multiplying you can do separate limits. Plus the limit delta x approaches 0. Let's do f of x plus delta x g of x minus f of x g of x divided by delta x. Now we can take out like terms. Equals limit as delta x approaches 0 of f of x plus delta x. That's a like term in this part. Times limit as delta x approaches 0. I'm skipping a couple steps here. So we have f of x plus delta x is our like term, so we have g of x plus delta x minus g of x divided by delta x. Plus, let's continue over here. So we have plus limit as delta x approaches 0. So our like term is g of x times limit as delta x approaches 0 of our f term is f of x plus delta x minus f of x divided by delta x. So if you look closely at these terms, this is just g prime of x, and this is just f prime of x. And here, because delta x is approaching 0, we can just say that this is f of x. So, as a result, d dx of f of x g of x equals f of x g prime of x plus g of x f prime of x. And that's our product rule. So the next topic of discussion is going to be the quotient rule, where we'll be using a similar technique to obtain, through algebraic manipulation again, the definition of the quotient rule. So let's say that we have some f of x over g of x. Now also, just to keep in mind, you could also, if you don't want to memorize all these two rules, you can kind of put this into here by turning the denominator into a numerator with the negative exponent. But we're not going to be worrying about this for now. For now, I want to derive the quotient rule and show the quotient rule as it can be used. So, once again, we're going to be having f of x plus delta x divided by g of x plus delta x. And once again, I apologize if my handwriting is small or terrible. My handwriting is both small and terrible. So here we want to turn this into one term. So the way how are we going to do this? So we want to do cross multiplication. So we have f of x plus delta x times g of x. Oh, let's not forget we have the limit as delta x approaches 0. So limit as delta x approaches 0 minus f of x g of x plus delta x divided by, and I'm going to skip a couple steps here again just to save boardroom in time. H times g of x plus delta x. Basically what we're doing is multiplying these terms together and then bringing the h up here. So here we're going to be doing another algebraic manipulation. We're going to be adding and subtracting f of x g of x. So limit as delta x approaches 0 of f of x plus delta x times g of x minus f of x g of x plus delta x plus f of x g of x minus f of x g of x. And once again, this is effectively adding 0 divided by h times g of x times g of x plus delta x. Now, another thing that we can do to make this a little easier is taking this outside and making two separate the product of two separate limits. So I'm going to be skipping a couple steps here. So I'm going to be doing this, and I'm also going to be rearranging the stuff in the numerator to make things a little neater. So we have limit as delta x approaches 0 of 1 over g of x, g of x plus delta x, times the limit as delta x approaches 0 of f of x plus delta x times g of x minus f of x g of x divided by delta x. Let's just keep it all under one limit for now. Plus, so what are the terms that we have left? Plus f of x g of x minus f of x times g of x plus delta x divided by delta x. But let's fix this also. This should be delta x, not h. Okay. Sorry about the confusion. I sometimes interchange between h and delta x. And this, to keep things a little less complicated, I'm going to keep it in delta x so that we can see x plus delta x and understand what it means. Okay, so we're going to once again factor out like terms. And I want to change this around a little bit. And you'll see why in a second. So the plus is the same as negative, negative, plus. So let's go over to this side of the board, and we have limit as delta x approaches 0 of 1 over g of x plus delta x times the limit as delta x approaches 0 of, so our like terms here are g of x times f of x plus delta x minus f of x divided by delta x minus the like terms are f of x and I'm going to carry this down into the next row. So our like terms factoring out is g of x plus delta x minus g of x divided by delta x. So we can bring the limits across everywhere and evaluate our limit here. So once again, as we did in the product rule, we can say that the limit of g of x plus delta x as delta x approaches 0 is g of x. So we have 1 over g of x squared times g of x. The limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x is f prime of x minus f of x times this, which is g prime of x. So we can bring that all into the numerator for our quotient rule. So I'm going to just rewrite the derivative. d dx of f of x over g of x is equal to g of x f prime of x minus f of x g prime of x divided by g of x squared. So that's our quotient rule. And the final discussion of this video, the final topic of discussion in this video is going to be the chain rule. And we're not going to be doing anything overly rigorous. We're just going to be using a few definitions from limits and derivatives that we have developed in previous videos to derive the chain rule. So say we have some function f of g of x, and we want to find the derivative of f of g of x. What we'll want to do, this is going to just be showing you briefly, and then I'm going to go into a little semi-rigorous explanation for this. So what we want to do is find the derivative of this. So we want to turn g of x equals u. Let's call it some variable u, such that we can define d du df du. And that is the same as d dx of f of g of x. That's the same general idea, at least. There are some other things that we want to worry about, though. So how are we going to come up with our expression for the chain rule? So what we want to define is some delta y over delta x is equal to delta y over delta u times delta u over delta x. So what we're trying to do is find some relationship between delta f of u and df du and d dx of f of g of x, because these aren't equal, but there is some kind of relationship, and this is how we're going to find it. So we want to find dy dx. So how are we going to find dy dx? So what is dy dx? dy dx is equal to the limit as delta y and delta x both approach 0. of delta y over delta x. So what we need to use is limit as delta y, delta u, that's a y, not a u. Delta y times delta, that's another y. Delta u, as delta y, delta u approach 0, of delta y over delta u times the limit as delta u and delta x, it's not, of delta u over delta x. And this is as that approaches 0. So we can do this because if we want to take the limits, so the limit of delta x, delta y, and delta u all approach 0, of delta y over delta u times delta u over delta x. We come to this because of the product rule of limits. And if you also look, the reason why we're able to do this is because if you treat the deltas as algebraic variables, you can get rid of these delta u's and you end up with delta y over delta x. So if we define some y in terms of u and some u in terms of x, this is basically what we're doing here. So if we do this, we just have one final expression, dy dx, will then equal dy du times du dx. Which is the chain rule. So thank you for watching the video on these proofs. The next video we are going to be using the product rule, quotient rule, and chain rule in examples, and that will be it as far as the introduction to derivatives are concerned. And then after that we'll be running into some of the applications of derivatives. So thank you for watching. Once again, please subscribe if you haven't already, and please keep an eye out for any future videos, and thank you for watching. I will see you again soon.